Hi, welcome back to the breadboard. Today we're going to have a close look at a new power supply option that you have for the bench for charging USB devices or powering your projects like Arduinos, Raspberry Pis and things like that. If you look what I have on the bench here, let me just bring you a little closer. What you can see here is things like an Arduino Mega or a Raspberry Pi with relay board plugged into it, an Arduino Uno, a couple more Raspberry Pis, basically 2, 4, 6, 7, 8 different boards here. All of them have a common theme in that they're powered from 5 volts. Now some of them you can power from 5 volt at half an amp or less, like the Arduino Unos and things, provided you don't have other things connected to them. But Raspberry Pis, especially if you put like this one, you put an LED or LCD display on it, you need a power supply that's about 2.5 amps at 5 volt. So what do you do if you're like me? I'm often working with a lot of different things all at the same time because I'm developing maybe a central control system for a home automation with some edge devices, another Raspberry Pi acting as a gateway or something like that. So you got all of these things that you want to have powered on all the time. So you end up with a great big pile of adapters, mains adapters, right? And that's a pain in the butt, especially when you look at your power strip like this one. This is a typical one that you can buy. They nearly always have the power, so the cable comes out, but your orientation is such that they go that way. Well, how do you get this next one in? It doesn't fit, so you got to skip one. And then you have to skip another one and put another one in, unless you use these little ones, and these little ones typically don't have the same power rating. So that doesn't work very well. And you've got all of these things, and you have to have a honking great big mains extension breakout so that you can get the extra sockets and all that kind of stuff. It's pretty much a pain in the ass. And the same, even if it's not for your projects, if like my house, 2 kids, 2 adults, we're a technology kind of family, and so we have, everybody has a smartphone. We all have devices that use 5 volt chargers, USB, so you've got your smartphones, you've got your tablets, you've got MP3 players, all kinds of things. So you want something that you could maybe put in the house somewhere where everybody could plug their things in to have charged, but that you don't have separate chargers all going at the same time. A company called Xtar has sent me one of their USB power supplies that in a lot of situations will fix those issues. For me, should fix them for the bench when I'm running lots of projects and I want to have lots of things plugged in. It looks like a USB hub. This is it here. It's the Xtar intelligent USB charger. It's a 6-port USB charger. It's not a hub, okay? So you can't plug your computer in it and then have 6 devices plugged in from that. It's direct mains powered 6-port USB charger, and they say it's intelligent, and also it says that it has a max of 2.5 amps per port, but the charger itself is limited to 45 watts. So that would mean that you have a total draw through all of the USB ports of about 9 amps, 9 amps at 5 volts, 45 watts. But you can have several of those ports running at 2.5 amps each, and the rest of them running at a lower output voltage. So I haven't tried this yet, so let's get on the bench, have a look at it. First of all, we'll have a look at the outside. We'll load it up with a few different things, see how well it works. And I'll see if I can load it up a little bit to test the current consumption or the current output capability on one of the ports, and if I can, we'll have a look inside it to see what it's made of. I'm not sure if I'm going to be able to or not, depending on how it's constructed. But anyway, let's go have a look at the bench and see what it can do. So this is the unit, just taking it out of the box, and as you can see, it's pretty solidly built. It's plastic case on it. You've got the 6 USB output ports, got a little indicator LED by the look of it, and on the back of it, it's got a mains connector, and you get a mains lead with it, 2-prong. It's not keyed for not live and neutral or anything, so you can plug it in either way around, but it is, as it says here, double insulated, CE approved, etc., etc. 45 watt 6-port USB charger. So it says output 5 volts, 9 amps, each 2.5 amp max, sorry, 2.4 amps max. So I have this array of components to all hook up to it. So we'll put all of these on at once and see what happens. I have a Raspberry Pi with a 7-inch display as well that we can hook up and see what happens. Now usually if this starts detecting a low voltage, it will put a little rainbow or some indicator up here to say that it's the voltage is a little low. So, you know, all of these adapters over here, we don't want to use these. This is a pain in the butt. Now, I mentioned about most of the power strips not having the orientation correct to make use of these. But if you do shop around, you can find some. I actually just had another look around and I found this one. And what you can do with this one, of course, because of the orientation, it will let you stack a bunch of these in a row. That's a dual output one, so that you can get them. But you still need, you know, your power brick. You've got all these individual power adapters. So overall, it's not as efficient as having one power supply and being able to do all of that. And if you're using bigger ones with 2.5 amps and things, it's just a lot of cables. Usually your main socket is not where you want to use it, and so you got to run the extension lead or longer USB leads and things like that too. So this is what we're trying to avoid. These will either be chargers or, you know, for your smart devices, or they're going to be powering all of your projects. In my case, I'm more interested in powering all my projects for the moment, although I think I will be using it also for charging, you know, as a central house charger or something. Maybe I'll get a second one. So anyway, let's get this thing hooked up and have a look. And see how well it goes. We'll try and measure the output voltage. I'll get a breakout USB lead. We'll measure the volts that are coming out of it and the kind of currents that are coming out, and see how well it maintains that while we load it up with a number of devices. Okay, so I've just powered up the Xtar 6U intelligent USB charger, and as you can see, I've connected my RS Pro digital multimeter to it. We're reading 5.21 volts right now. So let's try connecting the Raspberry Pi up first to see how well the voltage is maintained. We'll just keep monitoring on the end port of this. We have a DMM connected to it right now, as you can see there. So we'll hook up the Pi. Just back out the picture a little bit so you can see it all. And see how we go. 1 second. So that's the Pi booting up again from its restart, and we'll see if the volts is holding okay, and it seems to be. And the volts on the meter seems to be still 5.2, so that's good. I have a little USB current monitor somewhere, but I can't seem to lay my hands on it, so I'll have to find some other way of measuring the current draw. I think I might just put a mains powered meter on and see what we're drawing from total from the mains, and we'll just do the calculation down to the USB. So let's get a few other devices hooked up now. We'll hook up this Arduino Mega next, and we'll put a couple of more Raspberry Pis in because we know that they draw more current. So that's one. Let's use this Raspberry Pi that has a relay shield on it as well. I don't have any code in here, but we'll just boot it up anyway. It will still, now I'm using shorter leads too because this is a thin lead, so really if you run a long one it's not going to work properly for it. We have an Arduino Uno here, so we'll connect that one up as well. And we'll take an Arduino Uno over here and we'll hook this one up as well. It's got a bit longer lead, but it doesn't. So there we go, that's that on. So now we have 1, 2, 3, 4, 5. Oh, plus of course the other thing. So what I'm going to do then is hook up my DC load, I think, to this. So I'm going to put this, my DC load that we built in a previous project, it's now repaired. I'm going to do a separate video. I'm in the process to do a separate video to show you how I fixed it and what went wrong. But what we'll do is we'll load up one of the ports to the full extent of 2.4 amps and see what happens. So let me just reconfigure this so that we can see that. The actual DC load will indicate the volts and amps anyway directly. So we don't need this anymore. We can take that out. And we'll bring this in. Just wind the current down to nothing. We need a 12 volt power for it somewhere. I had that here before. So you can see here we've got 5 volts, and that's just milliamps right now. And everything else seems to be working just fine. As you can see, the volts is up. So let's increase this current now to see where it's if it tails off. So we're about half an amp, just over. Still 5.11, 5.0, 1 amp, 4.9. We're up at 2 amps, it's at 4.88, so it's still within spec, but it's getting on the low side, so that's 2.3, 4, 5. Let's crank it up a little bit further and see how much it will let me. Yeah, it's going down, that's about the limit now, 4.75. USB would allow it to go a little bit lower than that, but as far as I'm concerned, 4.75-ish is the 5 volts plus or minus 5%. So we'll crank it back down to, certainly we could go over the 2.5 amps. So let's just go back to 2.5 amps right there. So that's what we're loading up on one of the inputs to here. Now I'm going to take my meter now, just going to grab a couple of regular probes, and we'll see what volts we've got on the other inputs, or inputs to the equipment, outputs of the power adapter. So let's just move this off to the side a little bit, make room for the meter. We'll put this to 20 volt range, and let's see what we're getting at various places. So this is on the Arduino Mega. What's a good place to measure 5 volts? Probably on the input to the, so we get that in the right range. Input to the voltage regulator. So that's at 5.06. So that's good. Good place to measure 5 volts on one of these, on an Arduino, on a Raspberry Pi. I think across the, there we go. I got the probes the wrong way around, but we've got full 5 volts on the Raspberry Pi here. And we could probably check on another couple of devices too, but I think we'll be finding that we've got 5 volts consistently across all of them. Let me just increase this load a little bit more, say take it to 3 amps, just to see what happens. So that one is now reading 4.73, so it's still not doing too bad even with 3 amps coming out of one of the ports on here. We've got 4.73 volts at 3 amps, and we'll see what we've got on the Raspberry Pi again. Let's get the leads the right way around this time. That's ground and 5 volts. So we still got 5 volts. So even though I'm dropping this one, it's not affecting the other outputs at all, which is nice. So that shows that they are independently controlling the outputs. Now, of course, the other thing with this DC load is that's reading 4.73 volts, but that's at the end of the wires on here. So we could have a drop on the wires of the DC load. So let's just measure as close to the USB port as I can, which is on the probe tips. So that's 4.97. So I'm actually dropping 200 millivolts on these probe leads at 3 amps. So that's quite a lot of drops, and that's something you know, we've talked to, or I've talked about it in other posts, where if you don't use good enough quality leads. You know, we've got 4.97 and then we've got 4.72. So we're dropping 250 millivolts across these instrumentation probes just due to the current. Right? The voltage measurement is directly on these pins, so it's only the load that's on these instrument cables, and these are quality silicone leads. They're not getting warm or anything, and we're only drawing 3 amps, but as you can see there, 250 millivolts is a lot. So if you're trying to power your projects with 5 volts and they do actually take a couple of amps or more, you can see that it's very critical that you use good quality USB leads. Now I will do a separate video on USB leads. I did a blog a couple of years ago where I evaluated some USB leads for the Raspberry Pi because people were complaining about the rainbow and it crashing and things like that, and I showed the different construction of some Raspberry Pi leads and why it mattered about getting short and a good quality lead as possible. And you know, when you look at these, for instance this one here, it's pretty thin, and I can guarantee you if I open that up it's going to be very thin inside. In fact, I have a, you know, aside from this USB lead that we're using down here for this, let's just zoom in, you can see they're pretty thin. This is not a good quality lead, which is why it's cut in the first place, because I was looking into it. I'm just using it to measure the volts and things. So, and if I grab another one that I have laying around here somewhere, this is another one. So I showed you that one and the wires were not too bad on it. This one, as you can see here, these wires are really thin. Like this cable is one of the crappy ones. It's you know, it's a USB data charging cable, but the thickness of these leads, they're just awful. And if you try to use these for anything with high current to a Raspberry Pi, and a lot of people will try with just a lead like this, obviously with the end still attached, and they'll be surprised why the Raspberry Pi keeps rebooting. So we can see here that we're drawing over 3 amps out of one of the ports and we're still up at 4.72 volts, which makes it more than enough to be able to charge pretty much any smart device. What I want to do now is see if I can get into this without breaking it, because I do, as I said, I do want to be able to use this thing safely. But you can see here how useful this would be to connect up to a number of devices. In my situation, for development reasons and stuff like that, where I can have a lot of devices connected at the same time. So the Xtar 6-port USB charger certainly looks good value. I don't know how much it is. We'll put a link to the Xtar site in the posting so that you can see. In fact, I'll edit it into the video as well. This is not getting warm at all from having it loaded up at 3 amps on here. Mind you, the whole thing is rated at 45 watts, so I would have to somehow try and load up a few more channels if I could to do that. And I don't currently have a DC load of any kind, except for the one I've just been using on one of the channels, to see how this works. But what I do want to see is look inside and see how it's built, if we can do that. So let's have a look at that now. So I've had a good go at trying to figure out a way to get into this, and it is probably ultrasonically bonded together. It is not giving me any option to try and crack into this without completely destroying it. And I don't have a second one, and I do want to do some more testing with this. I've got some, or I'm working on getting some more load so that I can load up a few of the ports at the same time, so that we can actually fully load this, and also to test some other power supplies and things. So I don't want to destroy it, certainly not yet. But just to summarize, this is the 45 watt 6-port USB charger from Xtar, made in China. They sent this to me at no cost to me to have a look at and to use for my projects. And from what I can see here, you know, we saw I loaded up one channel to 3 amps. I had another channel with a Raspberry Pi and a LCD display running from it, and it was not indicating low power or anything like that. And at the same time, I had all the other channels loaded up with Arduinos, with Yuns, and even another. So I had 3 Raspberry Pis running off this thing at the same time. Sorry, 2 Raspberry Pis and a DC load, as well as the other devices. So that's a pretty good indication that this thing is going to be solidly built. I'm going to try it with a few other things, maybe try charging a bunch of devices on their own in a separate video once I get some more good quality leads and things like that, so that I can actually cut them up and make some proper loads for this. So that, as I said, that's a quick look at the Xtar charging intelligent charger. So that completes the review of the Xtar 6-port USB charger. I hope you enjoyed the video. If you did, give it a thumbs up. If you didn't, that's okay too. I will see you on the next video. Bye.